Hello, everybody. This set of notes is going to be over 3.6 using CPCTC. CPCTC stands for corresponding parts of congruent triangles are congruent. Congruent triangles have congruent corresponding parts. If you can prove that two triangles are congruent, then you know that their corresponding parts must be congruent as well. So far in this class, we've talked about 5 different ways to prove congruency. Got side, 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 angle, side, angle, angle, side, angle, hypotenuse, leg. So let's say that I have these two triangles here, and I have proven that these two triangles are congruent by side, angle, side. Now that I know that they're congruent, then any of the other parts that I did not originally mark as congruent can be marked as congruent. So for example, I now know that this bottom corner will be congruent to this bottom corner. Okay, you've got angles that are congruent. The second thing that I can mention is this side is congruent. And then just based on this example that I gave, we have this other angle over here that is also congruent. Okay, so remember that triangles have 6 pieces of information, right? They've got 3 sides and they've got 3 angles. You need 3 of those pieces of information to prove congruency. But there are still 3 other pieces that exist. And those 3 pieces are what we are going to be able to say are congruent using the phrase CPCTC. Now, we use CPCTC if we are trying to prove something other than our triangles are congruent. So in everything that we've done so far, 3 through 3.5 or whatever it was, our whole goal was to prove that our triangles were congruent. That was always the last statement that we had in our proof. However, what we're going to be looking at today is how to prove other things are true. So for example, in this picture, we need to prove that EB bisects angle FED. We're no longer proving triangles are congruent. So if on a quiz or a test, you see something that says prove this, other than prove that these two triangles are congruent, in your brain, you should say, ooh, I'm going to be using CPCTC. And I'm going to kind of show you how to use CPCTC, and I'm going to make it as easy for you as possible. So this first example here, I've given you some information. I've told you that DB is perpendicular to AC. Remember that when you have 2 perpendicular lines, you end up with congruent right angles. We also know that D is the midpoint of AC, therefore AD will be congruent to DC. And then it says triangle ABD is congruent to triangle what by what? Well, if you look at your picture right now, we have, so for triangle congruency, we've got angle 3 congruent to angle 4. We've got AD congruent to DC. Remember that we need 3 pieces of information to prove congruency. The last thing that I'm going to be able to say is true is that BD is congruent to BD. I now have 3 pieces of information, which is enough to prove congruency. So triangle ABD is congruent to triangle CBD. And if you look at your picture, that is true by side, angle, side. So now what's going to happen is now we need to list the other congruent parts. And remember, I need 3 because there are 6 pieces of a triangle. Now that I know that my triangles are congruent, I can say that angle 1 is congruent to angle 2. So that's my CPCTC option down here. Angle 1 is congruent to angle 2. I also know that AB, side AB, is going to be congruent to side BC. AB is congruent to side BC. And then the last thing I know is angle A is going to be congruent to angle C. So if you look up at the top right here, these are our 6 pieces of information that we need in these triangles. So we've got 3 sides and 3 angles. So what we have to do in order for us to use CPCTC, we have to first say that our triangles are congruent because we don't have any corresponding parts of congruent triangles if we don't have congruent triangles. So your first step with a CPCTC proof is to prove that your triangles are congruent. We're going to use side, 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 angle, side, angle, and hypotenuse leg, just like we've always done. And then after that, after we have proven our triangles are congruent, then we will put in our CPCTC information. Okay? So looking over here, we have another example. We have that AB is perpendicular to DC, and we have, that's all we have. Okay, great. So now that I know that angle 1 is going to be congruent to angle 3 because that's what happens when you have parallel lines. You have angle pairs. I know that AB is congruent to DC because it tells us that right there in the given. And then the other thing that I know without needing to be given any information is that AD is congruent to itself. So I can say that triangle ABD is congruent to triangle DCA, and that's going to be by side, angle, side. Why do we have two side, angle, side problems? Side, angle, side, side, angle, side. Weird. Okay. So our CPCTC options are going to be the other things that I can now mark congruent. I can say that side CA is going to be congruent to side BD. I can say that angle C is going to be congruent to angle B. And then the last thing I have is that angle 2 is congruent to angle 4. Cool? All right. So here it says, once you prove two triangles are congruent, you will consider your CPCTC options. So those are the red options that I have there. Then you will choose one of your CPCTC statements to help you complete your proof. Your proof can end with CPCTC if you are trying to prove that two parts are congruent, but sometimes you might have to go further than that. If you're trying to prove something other than congruent parts, like a segment is an angle bisector or a point is a midpoint, then you'll have additional statements after your CPCTC statement. If using CPCTC, the end of your proof must look like this. So you're going to have your two triangles are congruent by either side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg. So here is your triangles are congruent. And then right here is going to be one of your CPCTC options, and then your reason will be CPCTC because you've grabbed it out of your CPCTC option list. So best way to do this is just throw you into it, okay? So we've got some given information. Notice that our proof is something other than congruent triangles, so I still have to prove my triangles are congruent, but then I got to start using my CPCTC stuff. So first thing I'm going to do is write down my givens. BD is perpendicular to EC, and BF is perpendicular to AE. Those are the same types of givens, so I'll go ahead and put those on the same line. So BD is perpendicular to EC, so that would mean that angle 7 and angle 8 are right angles. And then BF is congruent to AE, so angle 5 and angle 6 are going to be right angles. Now, looking at this picture, that's a lot of information that I need to be writing down, but I don't need all of this information. FBD. I'm pretty sure I don't need this triangle down here and this triangle down here. So I'm not going to include any information about angle 6 and angle 8. So step 2, I need to write down that angle 5 and angle 7 are right angles. My reason would be that's the definition of perpendicular. Remember, with perpendicular lines, you've got to do 2 number 3s here. The first one is going to be that angle 5 is congruent to angle 7, and that is all right angles are congruent. And then your other option would be that triangle FBE and triangle DBE are, are right triangles, and that's going to be definition of right triangle. I got to go back and remember the, mark one of those out at the end. Okay. So I do have an angle, helpful, but now I got to find other things. Okay. So that takes care of this guy and this guy. Now, my fourth option says that EB bisects angle FBD. Remember that when you have an angle bisector, you get two congruent angles. So that's going to be some angle something is going to be congruent to angle something here. EB bisects angle FBD. So that would mean that angle 3 is going to be congruent to angle 4. So angle 3 is congruent to angle 4. My reason would be definition of angle bisector. Again, I've got an angle. Still not enough to prove congruency, so I got to keep going. 6. We've got, I don't have any more givens, so I'm going to be looking for vertical angles or the reflexive property. I have the reflexive property here. So EB is congruent to EB, and that is the reflexive prop. That is a side, and I now have enough to prove congruency. So that's going to be step 7 for me, is to prove that these triangles are congruent. So triangle FBE is congruent to triangle DBE, and my reason is angle, angle, side. Now, because that's angle, angle, side, I need to go back up here and I need to get rid of my second number 3, which is my right triangle information. Okay, but remember that I'm trying to prove that EB bisects angle FED. Okay, so now that I've proven my triangles are congruent, I'm going to come up here and I'm going to make myself my CPCTC list. And this is where I have to list the 3 other congruent parts of my triangles. So when I look at my triangles, oh no, what happened to number 4? Okay, so when I look at my triangles here, I've got that FB is congruent to BD. I've got FE is congruent to EC, and I've got that angle 1 is going to be congruent to angle 2. Now, notice that none of those are that, okay? But what I need is I need one of those CPCTC pieces of information to help me prove that EB bisects angle FED. So if EB were to bisect angle FED, then that would mean that angle 1 and angle 2 are congruent. So essentially, I'm thinking about this backwards. If EB bisects angle FED, then angles 1 and angle 2 would be congruent. So I need angle 1 being congruent to angle 2 to help me. So what I'm going to have to do first is I'm going to have to mention that I have angle 1 being congruent to angle 2 by CPCTC. I'm running out of space. Angle 1 is congruent to angle 2 by CPCTC. And I just grabbed that from my CPCTC list, right? I just grabbed it from there, which is why it's there. And then my last thing that I can write down, which would be number 9, I'm running out of space, I apologize. Number 9 is going to be that EB bisects angle FED, and my reason is just definition of angle bisector. Okay, so that is how CPCTC works. Hopefully that makes sense. Okay, I am going to grab and shrink, grab and shrink, grab and shrink, so that it all fits here-ish. Close enough. Okay, moving down, doing my second proof. Here we have AB is congruent to DC. So my first step is going to be that AB is congruent to DC. That was given to me. That's already a segment marked congruent, so that's one less thing I have to worry about. Yay. All right, number 2, we've got that AB is parallel to DC. That was also given to me. Now, AB being parallel to CD doesn't give me congruency. So that means that from that information, I need to figure out what is congruent. And remember that when you have parallel lines, you have angle pairs somewhere. So I can say that angle 3 is congruent to angle 2. Here's angle 3, here's angle 2. And they are congruent because if you have parallel lines, so if lines parallel, then we can say that alternate interior angles are congruent. Okay, so there's an angle that I have marked congruent now. All right, fourth step. I'm out of givens, so I'm looking for either the reflexive property or vertical angles. I've got the reflexive property. We've got AD being congruent to AD. That is my reflexive prop. And now I have enough information to prove that my triangles are congruent. So we would say triangle, and because we don't have triangle names, we can kind of name them whatever we want, but because we're talking about congruency, the order matters. In whatever you name the first triangle, you got to copy that order for the second triangle. So I'm going to start with triangle ABD is congruent to triangle DCA, and that is going to be side angle side. And now that I know that those two triangles are congruent, I'm going to come up here and make my CPCTC list. I need 3 other congruent parts. So we could say that angle 1 is congruent to angle 4. We've got CA is congruent to whatever the side is over here. We've got CA being congruent to DB. And then lastly, we've got angle C being congruent to angle B. Now, I'm supposed to be proving that AC is parallel to DB. So if, oh Lord, if AC was parallel to DB, then I would know that angle 1 is congruent to angle 4. So I got to go backwards. If these lines are parallel, then I'll have those congruent angles. But I'm trying to prove lines parallel, so I need my congruent angles, which in this case is my very first option. Angle 1 is congruent to angle 4. So that's what I have to write down next. Whoa. We've got angle 1 is congruent to angle 4. That's from our CPCTC list. And now, because I know that those angles are congruent, I can say that AC is parallel to DB, and my reason would be if, I gotta go back, I gotta do the converse now. If alternate interior angles are congruent, lines are parallel. And that is how you use CPCTC to prove things other than congruent triangles. If you have any other questions, please go see your teacher during their normally scheduled tutorial times, and I will see you in the next video. Bye.